2.1. Use inductive reasoning. Vocabulary. A conjecture. A conjecture is an unproven statement that's based on observations. We make conjectures all the time. If you see someone with a frown on their face, you may say, oh, they must be unhappy. Or if you see someone wearing a jacket, you might say, oh, it must be cold outside. Now, some conjectures can be true, and also some conjectures can be false, because I know a lot of kids wear jackets all through the summer. Inductive reasoning. Inductive reasoning is finding a pattern and then writing a conjecture for a general case. Okay, most of the time we hear more about deductive reasoning. That's finding evidence, like police do, and then going back to what must have happened. Inductive reasoning is the opposite. So it's finding a pattern and then writing a conjecture about what may happen later. Again, this may be true or false. Say that you bought a gallon of milk and it lasted a week. And then you bought another gallon of milk and it lasted another week. You could probably make a reasonable conjecture that if you bought a third gallon of milk, it would also last a week. Now, again, that may be false because you may need more milk one week than another week. So we have to be really careful with inductive reasoning. But again, it's something that we use every day. So we find that, have you ever been stopped at a stoplight and then watched 3 cars go by and watched 3 cars more go by? And so you make this conjecture that you'll be able to go maybe the third time the stoplight turns green. Well, that really only depends on the cars in front of you. But usually we can, or it's usually good to wonder about such things, because then you can help predict what will happen later. Okay, a counterexample. A specific case for which the conjecture is false. Let's see. How about a number plus another number is always bigger than either one of the numbers? Well, to disprove that conjecture, all I have to do is give one counterexample. I can give 1,000,001 examples where this will be true, but all I need is one counterexample to prove it false. Like 7 plus 0 is not bigger than 7. Alright, example 1. Describe a visual pattern. Describe how to sketch the fourth figure in the pattern. So first we have to figure out the pattern itself. So we have a block on figure 1 that's divided in half, and the bottom is shaded. Figure 2, it's divided again, and then the bottom left hand is shaded. Then it's divided again, but not into halves, it's divided into thirds. And then the bottom left hand is shaded also. So let's see what we can do with this. So solution. Each rectangle is divided into twice as many equal regions as a figure number. Okay, so it's important to also look at what number the picture is. So in figure number 1, it's divided in 2 pieces. Figure 2 is divided in 4. Figure 3 is divided in 6. Sketch the fourth figure by dividing the rectangle into 8. Shade the section just below the horizontal segment at the left. So 1, 2. That's 8, and so I would shade here. Okay, checkpoint. Complete the following exercise. Sketch the fifth figure in the pattern in example 1. Well, that should be fairly easy. Okay, start the video again when you're through. Example 2. Describe the number pattern. Alright, so we have the pattern -1, -4, and -16. -64. And then the dots. The dots tell us that this pattern goes on continually. So write the next 3 numbers in the pattern. First, we need to notice something about the pattern itself. The first number, how do you get from the first number to the second number? Well, do you see that we multiplied by 4? And by 4 again, by 4 again. So we can make a conjecture that the next number will also be multiplied by 4. So the next 4 numbers are -64 times 4 is -256. Then times 4 is -1024, and then -4096. So example 3, make a conjecture. Given 5 non-collinear points. Do you remember what non-collinear means? Non is not, collinear, co is same, line. So 5 points are not on the same line. Then let's make a conjecture about the number of ways to connect the different pairs. Well, a good way to do this is to make a table and look for a pattern. Remember that your table has to have the number of which picture it is in it, because you'll use that number in your conjecture. So if I have the first picture has 1 dot and it has no connections. Second picture has 2 dots and it has 1 connection. Third picture has 3 and it has 3 connections. 4 has 4 dots and it has 6 connections. Okay, and so what will the fifth picture have? Well, let's see how we get from the numbers themselves. To get from 0 to 1, we add 1. To get from 1 to 3, we add 2. 3 to 6, we add 3. So what do you think we need to add to get to the fifth picture? 1 more. So 4. So my conjecture is you can connect 5 non-collinear points 6 plus 4 or 10 different ways. Checkpoint. Describe the pattern in the numbers. Then write the next 3 numbers in the pattern. Remember, you need to say the first number is 1, the second number is 2.5. So you can have the number of the digits or the number of the picture first. Okay, on 6, rework example 3 if you are given 6 non-collinear points. Start the video again when you're done. Example 4, make and test a conjecture. Numbers such as 1, 3, and 5 are called consecutive odd numbers. Consecutive means in a row. Make and test a conjecture about the sum of any 3 consecutive odd numbers. First, we need to look for a pattern. So let's write some small odd number consecutive digits. So 1, 3, and 5. When we add those together, what do we get? 9. We can't quite make a conjecture out of that because we don't have enough patterns yet. So let's do another one. How about 3, 5, and 7? It's 15. How about 5, 7, and 9? 21. Then 7, 9, and 11. 27. What do you notice about 9, 15, 21, and 27? They're all multiples of 3, aren't they? Can I get any of these numbers, or can I get the pattern down if I multiply something by 3? Ah, it's the middle number, isn't it? So I take the middle number, multiply by 3, and I will have my conjecture. So 15 is 5 times 3, 7 times 3, and 9 times 3. So conjecture, the sum of any 3 consecutive odd numbers is 3 times the second number. Step 2. Test your conjecture using other numbers. Well, we need to look for some odd situations in here. So let's throw a negative number in. Negative 1 plus 3 is 3. Is that the middle number times 3? Yes. How about some big numbers? 103 plus 105 plus 107 is 315. Is that the middle number times 3? Yes. So we have proven our conjecture. Unless you can find any false ones, but there's not any. So checkpoint. Make and test a conjecture about the sign of the product of any 4 negative numbers. So again, start with small numbers, probably about 3, different patterns, and see about those 4 negative numbers products, and then try at least one odd example to make sure your conjecture is correct. So example 5, form a counterexample. If you haven't finished the checkpoint, go ahead and finish that now. Okay. A student makes the following conjecture about the difference of 2 numbers. Find a counterexample to disprove the student's conjecture. Conjecture, the difference of any 2 numbers is always smaller than the larger number. Well, at first, that seems correct, doesn't it? Like 9 minus 5, the difference between 2 numbers. That's 4, and 4 is smaller than 9 or 5. So I could see where the student would get this, but all we need to do is find one counterexample to prove this false. So we need to find a difference that is greater than the larger number. How can we do that? Well, again, with a strange example. How about a negative number? 8 minus a negative 4 is 12. And because 12 is not smaller than 8, remember that little line through something means not, a counterexample exists. The conjecture is false. So we can't have a conjecture. We don't want to use conjectures that are false in any situation or a situation. Our conjecture must be true always. All right. Next page. Making conjectures from data displays. Many scientists, journalists, people in government do this. So they take large amounts of data and they predict what will happen in the coming years. So here's a scatter plot. Remember, a scatter plot is a plotting of two numbers, and you can put them on a graph, and then you can draw or connect them with a line of best fit. This is from Algebra 1. So here's our scatter plot. NFL's average player salary. So years since 1999. So this doesn't mean year 0, because we didn't have football when the Garden of Eden was created. So this is, the 0 means 1999. So in 1999, did they make $700? No. This is the average salary in thousands of dollars. So they made $700,000. Sounds pretty good, doesn't it? Until you get all that brain injury stuff. So I don't know. Okay, $700,000. And then on year 1, so that would be the year 2000, the average salary was up, looks like it's close to $800,000. 2 is, 1,000, 1 million. Okay. So the values are increase each year. So one possible conjecture is that the average player in the NFL is earning what? Can we say a number? Would I be comfortable in saying 1,300? Because that's bigger than what the number is there, or 1,400? No, I probably wouldn't be comfortable saying a specific number. But I could say that they're earning more money today than in 1999. So checkpoint. Find a counterexample to show that the following conjecture is false. The quotient of two numbers is always smaller than the dividend. Let's just talk about the vocabulary words real fast. Quotient, again, is an answer to a division problem. And dividend is the number that is on top of the fraction, or if you're doing it the elementary way, inside the box. So 9 divided by 3, or 9 divided by 3, that is 3. 3 is smaller than 9. So again, at first glance, this would seem to be a true conjecture. But there is a way to make this false. You need to think of weird examples. Okay, on 6, use a graph in example 6 to make a conjecture that could be true. Give an explanation that supports your reasoning. Okay, Again, don't go for a specific number, but let's give a general statement about it. Maybe in maybe what do we know about the average salary in future years? So, give an explanation that supports your reasoning. Why do you think this from the graph?